Hello. We are we developed a research work in the field of robotics. We are calling we are presenting regarding of a versatile approach for adaptive grid mapping and a grid flex graph exploration with the FPGA based robot using of a hardware schemes. Right. Yeah, coming to us in today's challenge in indoor environment, estimation of the dynamic objects and also the static objects at a time, and proportionately developing of it's a exploration with respect of the grid. That was our contribution which we came out forward. Yes, there were few contributions are there already before us. But coming to us here, we are having of a adaptive grid mapping method we are developed over using of the our flexigraph exploration process. That comes to the point, the first one, the level one, we are going to have the sensor data. We prefer the ultrasonic sensors for the extracting of the data of the surrounding areas. We are using of a 8 ultrasonic sensors and we restoring of that information into the our FIFO. So once that FIFO is having of that data of the 8 sensors, based on that we calculate of our abstract kills, either it's a static object or a dynamic object with respect of the t of time. Then it confines that where exactly the object in the grid. So we notice that grid point. Right. From there, once the existing of objects are available, we confines whether it's a dynamic or static. Yes, it's a static. There is no chance to us to move from that part. So we take off a update of our grid construction. So from there, again it takes that and evaluates the distance-based frontier detection method. Once we do that job, next we will move for the again we use of a local occupancy grid frontier detection and explore the complete process, and then we move forward every iteration. So this was a regular process what we do until reaching of the destination point. That was our ideation. If you take into the account of these sensors, 8 ultrasonic sensors we measured over, whenever we are taking the steps ahead, left or right, we are having of the odometer, which we are saying as this odometer. We are calculating of a odometer internally by using of a computation techniques. So with the respect of a angle which we taken over from that point to the next point of the angle. So these were the odometer, the distances which we are calculating internally. Right, comment was a point here, the PWC sensor fusion model, which converts the distance of the ultrasonic sensors, which we applied for the exploration algorithm. Once we applied for the exploration algorithm, that exploration algorithm having of a, just now we mentioned of a, the 2 points, the distance-based frontier detection and a local occupancy grid frontier detection. So these two. From there, it comes to us the adjacent link checker module, then afterwards complete the exploration module. It confines that. So this information is continuously adapting by it's a by sensitizing of the environment and applied towards the left motor and the right motor to make robot to move from one point to other point. Yes, these are all these two are representing other setup of a dynamic objects, and this is about the inclusion of the static and dynamic objects we are having. These are results which we are achieved from our grid flex graph exploration resource utilization. Yes, if we observe, this was a generalized one, means a deploying of total complete algorithms of the both the static and dynamic, right? Means when we are having of a static and dynamic obstacles at that time, how the exploration and the grid environment is a adaptive mechanism we did, right? But we came out one particular thing is, yes, the static and dynamic, and also the other part is the distance based frontier detection for the both the dynamic and statics we are going to calculate using of a PR method. PR is a partial reconfiguration. So we used that particular partial reconfiguration with respect to PR at the environment with only dynamic objects. There is no obstacle like a static objects. So at that time, we developed our own architecture in that model so that it confines us the dynamic objects, right? Next one, we are having of a inclusion of a static and dynamic. So we are saying that a little bit higher architecture means the occupancy is more because we have to compute the type of obstacle which is a static. Among the static, what was exactly the static, can we move certain times, a semi-statics also comes into scenario, so that we are going to observe in this particular one. This was the utilization summary. We are saying as a LUT and a BRAM and a DSP slices. Fine. If we consider the just the LUTs, the 76.6% of the LUTs are occupied for the generic implementation. By using of a PR for the dynamic, we are having of a 43.57%. The next one is a little bit higher because having of integrity of the dynamic and static. Why a very small differences, because everything is a the computations are there, only the control part of the static is only changes over, so the 2.2% of the computational part of the LUT is improved here. That was the reason behind it. Yes, let comes to the implementation part. We are having of implementation regarding of our this particular one, when the robot is moving towards the it's a destination point, while the exploring of its a grid and so on, whatever we mentioned here. Yes, we are representing now when robot looks into the obstacle, dynamic obstacle. Here we observe this particular distances, right? With respect of that. Fine. Yes, we are also updating of our simplest part is the ultrasonic FIFO is there in a hardware, and a grid FIFO and vertex FIFO and object FIFO. All these FIFOs are going to have competition. So the grid occupancies which we are observing with respect of the video, right? Yes, fine. Now, yes, this was our previous what we have mentioned. This is second experiment which we conducted over for the static and dynamic. Here the dynamic object is here. Here the static objects are here. At the same time, our FIFOs are having of a sensory data. And the grid FIFO is having the grid. What's the grid status? What is the vertex status? And the object FIFO status. All the status are we are observing here. Right? Fine. This is the experimentational part. Yes, this is regarding of which we conducted over the experiments and fine. Yeah, we want to conclude of the what ultimately the end of the story is, right? Fine. We came out with a novelty part of our research work is a point number one. We are updating of a grid mapping. That was a point number one. Second one, with respect of a grid mapping, we are having of a exploration process too. These two are continuously dynamically varying. For that, hardware consumes more. So in that regard, we preferred our novelty is a partial reconfiguration technique was used, which is a part of the Xilinx. So we are utilized in this modeling and we achieved of that particular one with a very good results. Just now we mentioned about the by using of a PR, we achieved the results. Yes, thank you very much.